So today I will talk about a practical side of machine learning. I wouldn't call it day 2 operations, but rather 1.1 day or something like this. For more context, I will introduce myself. I'm an IT engineer with some experience in telecommunications and fintech systems. Today I have a DevOps title and do mostly web frameworks, setup, support, something like this. Mostly Java, less Node.js, front-end, back-end databases, you know, it's quite common, right? But at some point I got into machine learning, unintentionally I would say, but nevertheless it happened, so I will try to share maybe some experience. Okay. So what we had at the beginning of 20 years in DevOps and infrastructure management. In my humble opinion, we were at some point on this curve, reaching the productivity plateau. We got Terraform, TerraGrant, TerraMate, OpenTofu later, GitOps later, different clouds. I got into AWS. By the way, sets of certifications appeared, you know, these golden belts, Kubestronauts, Linux professionals, stuff. Looks like everything is certified and standardized, so productive. But suddenly, large language models made a leap behind. Data science became the new hype. I want to maybe remind, I used to study data science at Coursera in 2015. So it was 10 years ago. And this time it was mostly about MapReduce, some big data, solve some tasks in Kaggle platform. I remember that we built models to predict how to be a survived a person on the Titanic. And this time the data engineering probably also existed. Now it shines bright, but this time 10 years ago, it was also present. For example, in telecommunication mediation systems, if somebody is in telco, he probably knows what's the mediation. And it was quite niche job I had, by the way, without much money, without public appreciation, stuff like this. But I guess it's enough for grumping, old man's grumping. I mean, let's see what's now is new and shiny and like this. So I would say in machine learning it's Python. I'm pretty happy that finally Python became so popular. Okay, I will last time remind old times. I used to replace Perl scripts, if you know what the Perl was. I removed Perl scripts with Python ones in really early stages of my career. I guess it was successful. So I know Python, maybe, but I don't think all of it. If you also know Python, I can propose you this presentation. Link is above. It's not mine. I hope the author wouldn't mind I put it here. It's just to understand that for me it was just one of science. I don't know the whole Python because it's really complex. It's really science. Mathematics full now, and even from operations, from performance perspective, it's complex. The link, if you wish. What can help? I guess we have frameworks in IT, in Python also. The TensorFlow and PyTorch, I guess, most common frameworks. Here is a table where artificial intelligence helps me to compare. You can see that Onyx, it's called sometimes, it's not really a framework, but I put it here It's a format of models. I put it here in comparison because it's from the perspective of running. It's not about the naming, it's more about how you run. So ONNX is specific models in ONNX format are specific, and that's why I put it in comparison. What else is there? We can see that CUDA. CUDA is everywhere, it dominates, and I will show later why maybe. Also the managed services in the AWS, there are managed for sure services for machine learning, but today I will not talk about it, just skip it. What else except CUDA before I started with it? It's OpenCL and Neuron, which I know. It's again a comparison table. The last Neuron is vendor locked by AWS technology. It runs on specific types of VMs. It's inferentia Trainium. It's different variants, ages of it. It also has its specific CDK. So it's a thing special for AWS. OpenCL, in contrast, is possible to use, you can see, even on AMD devices, GPUs, I mean, as well as in NVIDIA. It's vendor neutral, looks promising, but at this point, from my humble opinion, it lacks support of frameworks. It's not very easy to set up. So today I opted for CUDA. So we'll start with discovering large language models with CUDA. A bit step aside, what else you should know about LLMs in 2025? I want to compare those two techniques. You should know those if you do machine learning, because it's those are two ways to compare to make language model more specific for business case which you have. First one, it's RAG. It's augmenting model with some data from external database. I will talk about it. It's called vector database. It's new brick in modern infrastructure. The first fine-tuning is another technique. It's about retrain the model. So it changes model itself. But I will it doesn't require some new bricks. So I will talk about vector DBs. So vector databases, a few words about those. Here we have few new words. It's embeddings. That's how data is interpreted in the machine learning world. So those are matrices, or vector. If it's one-dimensional, it's vector. Otherwise, it's matrix in common way. Nothing new. If you studied in a technical university, you know about matrices. So what we have here, the distance between vectors, similarity matrix, multiplication, dense sparse vectors, all those things I couldn't, I'm not so professional in those to speak about it today. But from infrastructure perspective, it's database. I worked with 4 of these databases in this table. So OpenSearch with KNN plugin and PgVector also as a plugin. It's another kind of, it's one kind of databases, because it's really a product with plugin. Well-known products, I think, very good at their field, but now they have specific for machine learning. I guess they are fine, but never tried in production. So can only get information or notify that they are good to some extent. So if you don't have a specific scale of production, they are good. And for huge vector databases, there's a Milvus and Weaviate. Weaviate I touched not very deep, but with Milvus spent a lot of time. It's probably was one of the first databases made by Chinese engineers, if you are fine with it. What I can say, they are quite matured, but at the start they were not so stable, I would say. I spent a lot of time doing backup and restore. It was kind of lottery if it works or it's not. But for large scale, I guess if you start with something huge in perspective, Milvus and Weaviate are good options. Okay, let's get back to large language models. Where to run those? So several options available, and I think the GPU is the best for now for parallel computations. GPU generally made for graphics, but it works for large language models, inference. They call running inference. You should know. But the performant GPU is not cheap. It's not cheap at all. It's also obvious. So if you want to do it cheap, you probably should rent a GPU. I work in AWS, but that's why I use spot instances for this example for educational purposes, I would say. What we have, EC2 types, it's virtual machines in AWS. I circled the important parameter. It's video memory. You will see later why. So we have 4 kinds of different ages, 2 with 16 gigabytes, 1 with 16 gigabytes, 2 kinds of different ages with 24, and the largest is 48 for now. The spot price of those one GPU model, it's kind of lowest, cheapest in available, between available. It's near $1. You can see the range. So you can try this new tech, just $1. I guess it's fine, should be fine. If to dig deeper, what's the GPUs inside? Here is a table. What we have for $1. Different ages it existed. Some of them are long ago existed. Some just released. Those NVIDIA video adapters, video cards, I would say. So let's get down to business. I'll present the recipe. Okay. What you should have if you want to try what I'm doing. You should have running Kubernetes cluster, self-managed node groups, cluster autoscaler, some GitOps. For usability and speed, I use Flux. And as a result, you will have Ollama. It's one of the ways to run large language models I opted for. And OpenwebUI, it's really important because its interface, you should have some interface to work with something. And those setups have 2 private volumes, 1 volume for OpenwebUI, and it persists. And 1 for Ollama, just to store models. GPU is on spot instances, so you don't have it always, but want to preserve the result of computations. That's why OpenwebUI has its own separate volume. Okay, let's start with demo. I hope I will manage somehow. No. Yeah, it all started. We'll try to follow it. Here is a Terraform code. I have showed that which models are already in place. If you have those controllers, you will get the PVC with all those models already in place. So when we start GPU, we already ready. So 1 model is even run. So it's Gamma with 12 billion parameters. Let's see it's ready and ask something. If you want to do I don't know, performance test for model, better ask for some story, because it's hard for model to create a story. So let's push it. Okay, the model started working. Let's switch to a place where we can see the contents. So here is a pod with Ollama. Those are the models from PVC which we had from the start, and one which is running. Let's also reach the node, actually the machine where the GPU resides. And here is another comment in NVIDIA SMI. It's quite important comment as a way to dig into NVIDIA stuff. Here we can see what's running, how much video memory consumed, how much power consumed, that it's doing something now. So we managed to somehow load this model. So let's switch back. It's still doing something. What's good in OpenwebUI, you can see that response tokens was 27. If you missed, I'm too fast because I do it often, spin up all this, but to explain is harder. What's new in OpenwebUI? You can, maybe not new, you can basically run 2 models, 3, 4, how much you have power for. And now we can regenerate the same with 2 models. So DeepSeek, for addition to Gemma, and the same tasks for both. We can see how it runs. Ollama shows we both are on GPU. This processor row was important because it runs 100% on GPU. It can also be not 100%. I will tell later. So now we have 2 models in parallel. Let's see how they perform. We can compare. First one already started, so it's the first, but next one will do something a bit later. What else is good in this I would say approach? Because we can do things for comparison. We can see what are the internal structure of what we're doing. I can tell in this presentation I haven't managed to get situation when it's partly GPU, partly CPU, but it's possible. Believe me, if you run larger model than fits to GPU, they utilize both CPU and GPU. But now we see second model, it's thinking model. I will also tell a bit about it later. So model with reasoning. And what's important for us to get it, you wouldn't like to wait long for the model. That's why it's better to have good parameter. The first one I will probably show now, we'll try to show it now. The parameter, how many tokens per second it gives us. So what's new in this newer versions of OpenwebUI? You can offload with this GUI, you can offload models. When the second will finish it works, we will try to offload. It's already done. So one of the models were offloaded. It's no more run anymore. And that's pretty much it for the whole idea how the OpenwebUI works. And later, now I will show the static screenshots. Not yet. Yeah, here the results, how we did it. So next are static screenshots, just to show how you can get use of it later when the GPU is expensive at some extent. So when you generated something, you can just stop the spot part of the system and have a PVC with questions with history, what you dig deeper into previously. So to the left side, you can see my questions, my experiments, which I did. So let's move on. Larger models, it's also possible. I used not so big models. Those models are, some of them have reasoning baked in. It's possible to run bigger, you can see later. There is also a feature when models are multimodal, so they can do text-to-speech. No, not text-to-speech, image-to-text. For now, of course, the public AI models have more sophisticated features, but for now, in this self-hosted variant, you can do the image explanation, maybe some discovery what's on the picture and stuff like this. What else is there? Those are coding models. Here I run two models, one for DeepCoder, it's from DeepSeek, and another from Mistral, it's recent one, DevStral, which should be good for coding. What I did, I asked them to do explanation and code generation of bubble sort in Python. They did it well. Also, just to play, I copied the code of this algorithm and put it in each competitor. So and asked, what can you say about this code? They were perfectly fine with their own code, but gave some optimization tips for another one, both. So I don't know. It's not only for coding, but also for some review, for code review. What may be not so good in Ollama, it states that CUDA can run in parallel on several, not the CUDA, but LLM can run in parallel on several GPUs. There are spot instances with several GPUs, but from my point of view, it's not ready. I managed to run it, but it's sometimes fails. So the Ollama crashes without any I don't know, debug, with nothing to analyze. So I switched to what's trying to discover what happened. I tried to see metrics. It's just a node with some CPU loads, with some memory consuming, but I couldn't get much out of this information. So it maybe will be better in later releases. That's what I'm waiting for, that maybe Kubernetes, maybe some metrics should be there, some logging should be there. You couldn't for now dig deeper of what's happening. What else? I also expect later the NVIDIA, new AMIs of AWS builds specific AMIs, specific images for nodes with GPU, with drivers for CUDA, with all underlying libraries, and this system is alive, so they now produce more AMIs with specific features. And recent discovery for me was that there are switches for GPUs, and they promise to do it. So I've read some NVIDIA documentation. What are the switches? Maybe it's something from distant future. Maybe not so distant. So what my conclusion? Self-hosted LLMs are, I would say, quite behind the public ones, the ones from giants of this industry, but they are catching up. So reasoning models, multimodal models, it's already present in Google, in ChatGPT, but now you can do it by yourself. It's interesting, I guess. And what else I can say, that we as operations engineers can learn LLM, machine learning in general by doing. So we have nothing to left that use previous experience to do the new journey. So if you've seen the series, you understand the analogy. That's probably it.